Welcome back to part 2 of the Pentium 2 series. Today we'll finish off this two-part series by showing you the PC setup with Windows 98 2nd Edition, the drivers for the sound card, the network card, and the video card. I'll roll some game footage so you can see the performance of the system for yourself, and we'll talk through some benchmarks, so let's get into it. Here we have the CPU details. We're using the Pentium 2 running on the Deschutes core at 400 MHz. We also have 16 kilobytes of level 1 cache and 512 kilobytes of level 2 cache. An interesting fact about the Pentium 2s is they were the first Intel chip to include the L2 cache on the processor card, which moves it closer to the processor, which is why the slot-based CPUs are so big. Here you can see the device manager showing the installed devices. I have the NVIDIA River TNT2 installed here using the 6.31 NVIDIA drivers, and I'll explain why in a moment. The 3-COM Ethernet card is also installed and working, which was a bit of a saga that I'll explain later too, and the Sound Blaster Live card is also installed and working. But before I continue, I just wanted to say a big thanks to Phil's Computer Lab for hosting all the old drivers you could possibly need for things like video cards and sound cards. So if you ever need vintage drivers for creative NVIDIA, AMD or Intel gear, head over and take a look at his website and check out his YouTube channel. Here is the DirectX version information. I'm using DirectX version 6.1a, which is fine as this card only supports DirectX 6 anyway. I did run into a weird issue with the NVIDIA drivers in the 3-COM network card though. I initially installed the NVIDIA 6.18 drivers, and before I had installed the network card, everything was working fine. I ran 3D Mark 99 a few times and recorded some results. Then, after I installed the network card and the drivers, 3D Mark 99 would now blue screen on the CPU tests. So I tried a few things, and after removing the network card, it worked again. So I figured there was some kind of conflict between the network card and the video card, but after checking the IRQs and the resources, nothing was shared. So at that point, I decided to try the next version of the NVIDIA drivers because nvcore.dll was the library that was causing the blue screen crash while the NIC was installed. So I updated the version of the NVIDIA drivers to 6.31 and it all started working again. So with that problem solved, I installed the Sound Blaster Live card and ran into another issue. The setup would not detect the Sound Blaster Live card no matter what software or driver version I selected. It wouldn't work. So with my previous knowledge about the network card, I decided to try removing the network card and setting up a Sound Blaster Live, and lo and behold, it worked first time. Now, I don't know why exactly the 3-COM network card causes hardware detection and driver issues with other devices. It seems to only happen if you install it before them. And I also don't know why it won't play nice with NVIDIA's 6.18 drivers. But the solution to the issues I was having here was to remove the network card, install the sound card, install the NVIDIA 6.31 drivers, and then reinstall the network card. And ever since then, the system has been stable and working fine. Looking at benchmarks, I ran 3D Mark in 800x600 at 16-bit color mode and in 32-bit color mode to get a comparison, as the TNT2 supports 32-bit color unlike some 3D effects cards of the era. The performance was noticeably better when running in 16-bit color, but it still performed pretty well at 32-bit. Expendable, running at 640x480 with 32-bit color, seemed to perform best for all the settings in that game, although it will also run nicely at 800x600 with 16-bit color, so that game's totally playable. Heretic 2 I tested as well. That's based on the Quake 2 engine and performed very well in OpenGL mode running in 640x480, pulling anywhere between 30 and 50 frames per second in most sections of the game. For me, this was absolutely playable with no problems at all. Even the underwater sections only went as low as 30 frames a second. So this game at 640x480 with OpenGL is totally playable on this machine. Also tested Wipeout XL, or Wipeout 2097 as it was known in some other countries. I test this game at 640x480 at 16-bit color and at 800x600 with 16-bit color, and while it ran the best at 640x480, this game appears to be frame capped at 30 frames a second. Also, some of the track sections with more textures, like the checkerboard pattern, caused some frame rate dips, but on average it managed to maintain a playable 30 frames per second most of the time. Quake 2 was another game I tested. Performance here was similar to that of Heretic 2 in 640x480 using OpenGL, which isn't surprising considering that both games use the same engine. So it looks like no performance optimizations were really made for Heretic 2 and the engine was just used as is. We also tested Quake 2 in 800x600 mode using OpenGL, and the frame rate capped out at around 30 frames per second, which is still playable on this machine, so it's kind of okay. It also highlighted an interesting artifact of the lighting setup. You can see here that when using 640x480 with the OpenGL renderer, the lighting is brighter than the 800x600 resolution. I'm not sure what's going on here and why the 800x600 OpenGL version is much darker. If anyone knows, please let me know in the comments. Another game that I tested was Test Drive Off-Road 3. This game performed the worst by far out of all the games I tested for this benchmarking video. This one's set up at 640 by 480 using OpenGL as the renderer, rarely pulled over 25 frames per second on most tracks. You can see here on this mountain track that it's struggling to pull over 22 frames per second, and it doesn't get much better. In fact, if you move to the forest track, the section with redwoods feels even worse when you're the one actually playing it. This game also doesn't give much in the way of graphics options. You basically set the draw distance and turn special effects on or off. Special effects seems to just be the dirt and dust coming from the car wheels while you're driving. Even so, with the draw distance at a minimum and special effects turned off, the frame rate still doesn't reach a smooth playable rate. This game would definitely be better served with a faster system or a faster video card. So here you can see the results for the expendable time demo mode. Looking at 640 by 480 at 16 bits per pixel, it's 40.76 frames per second, which was the most playable frame rate I could get out of it. Going on from that, you're looking at 800 by 600 at 16-bit color, and that's down to 35.72, which is still playable. It did have a few small dips when there were some explosions and things like that, but otherwise it was pretty playable. Moving up to 1024 by 768 at 16-bit color puts it under 30 frames a second. It's a little bit laggy, a little bit jerky, probably not the best. Then moving up to 32-bit color, we're looking at 33.69 frames at 640 by 480. Again, just within the playable range, but I would go back to 16-bit color if I was going to use this card and play this game. Then from there on down to 800 by 600 by 32, we're looking at 24 frames a second, and then at 1024 by 768 at 32-bit, it's 17 frames, which is totally unplayable for this game. Looking at Quake 2 now in time demo mode with the demo1.dm2 map, 640 by 480 with the OpenGL renderer gives us a maximum of 39.4 frames per second. This is the highest I could get on this card with this machine, so this is how I'm going to play it. Moving down from there is 30.2 frames a second when you move to 800 by 600, and then 1024 by 768 with OpenGL is down to 22.4, which was just a frame slideshow of a mess, really. I had to go with the software renderer as well, so looking at 640 by 480 with the software renderer, you're getting about the same performance as you do with OpenGL at 1024 by 768, so 22 frames a second, not very playable, and then it just gets worse from there for the software renderer. So OpenGL seems to be the way to go on this card with this machine. Happy with that, so I'll be playing Quake with OpenGL at 640 by 480. So, the one we've been waiting for. How many 3D marks does it get in 3D Mark 99 Max? So I tested this a couple of ways. As you can see, I've got some test results here with no network card installed, and some test results with the network card installed. I did some reading on the internet, and I read that having a network card installed may impact the actual performance of the 3D card. So I decided to test that out for myself, and it does. So with the graph on the left, you've got the red and the blue bar. The blue bar is the 3D marks, and the red bar is the CPU marks, because 3D Mark 99 Max gives you a ranking for your 3D card and for your CPU. So looking at 100 by 600 at 16-bit color with no network card, these are the default settings for 3D Mark 99 Max. The blue bar on the left gives us 3,550 3D marks with no network card installed. And if you look at the bar in the middle, the blue bar here, 800 by 600 at 16-bit color with the network card installed gives me 3,496 3D marks. So that's a loss of 54 3D marks. Now, I could replicate this. I did each test 3 times and it came out exactly the same each time. So there is a very, very small performance loss if you have a network card installed, which is weird. It's not sharing any IRQs. The only thing I can really put it down to is bus contention and wait states. So the network card is just using up some CPU cycles. You can also see that with the CPU marks, so 3,942 with no network card and 3,920 with the network card. So, I mean, these kind of numbers are not going to make or break gameplay. Losing 54 3D marks is really not much at all, especially on some of these older games. They're not performing at 60 frames per second anyway, so you're not going to really lose much. Then moving on to the 32-bit color, a bit lower, so we've got 2,836 3D marks at 800 by 600 with 32-bit color, and 3,906 CPU marks. So again, slightly lower than with a network card, and again, slightly lower than with no network card. So if you really want to push for bleeding edge performance, I'd say don't put a network card in your retro gaming machine if you really want to push the 3D marks. But, you know, for such a minimal loss in performance, it's really worth it to have the convenience of the network card so you can move files back and forth between your machine much easier. So there you have it, that's my Pentium 2 build. I'll be using this as my Windows 98 retro gaming machine going forward. Pretty happy with it. There are a few things that I would change. I'd love to upgrade it with a TNT2 Ultra if I can get my hands on one. I'd also consider playing with some 3D effects cards, so some Voodoo 2 or a Voodoo 2 SLI setup would be pretty nice in this machine. And the final thing that I'd love to upgrade would be the CPU. Even though I'm running the 400 MHz Pentium 2, I'd just love to have that 450 MHz, you know, top of the line P2. It's the last one of its kind. Just to have the 450 really, for no other reason than that. So there you have it, that's it for the Pentium 2 series. If you enjoyed my video and liked this content, let me know in the comments below. Don't forget to like and subscribe, and I'll make some more content like this, and I'll see you guys next time.